Yes, sir. வந்துருச்சு sir. Okay, sir. Okay, I'll start, sir. Very good evening to all present here. Our rocket science program, especially for this National Space Day. Since yesterday is our National Space Day, where our Chandrayaan 3 has landed on the moon, and the government of India is celebrating on this occasion. Today we have a wonderful session from Dr. Sasi Kumar. So Dr. Sasi Kumar is a scientist, senior scientist from Vikram Sarabhai Space Center from Trivandrum, ISRO, and sir has contributed a lot of particularly on the composite related work, and he's also was a quality person for various missions of PSLV, GSLV, Mark II, Mark III launches. And more than that, he's very passionate towards the students because, like, he has written nearly, I think, some 12 to 15 books, especially on the various aspect of science as well as on the rock and related to various engineering disciplines. So it is not that easy, I think, to make a book as being a scientist because he's having a lot of schedule. But his interest has moved towards because the knowledge is almost trying to benefiting to the entire world. The book of what you have written it. So maybe you people can even like after the session also, sir will be displaying some of the books list, and it's very important. Every book is very simple, but it always has a lot of visionary thinking and energy to have that. So, such a dynamic person, we have Dr. Sasi Kumar sir, and he has received a lot of prestigious awards from various forums, and including the Government of India. And he's also like a life member in various professional society, like Institute of Engineers and the IEISC, like Institute for Science and Engineering, and various other activities. So, with that short note, I would like to invite our Sasi Kumar sir to take up the session. Sir, over to you, sir.
Google
Thank you, sir.
Google language Tamil or English?
English also okay, sir, because some students have joined from Kolkata and Abu Dhabi, Dubai also is there, sir. Few students.
Oh, okay. Okay, then English must.
Yes, sir.
Okay. Okay, then some slide I have put in Tamil also, no problem. Hope I am
Okay.
audible. My slide is visible to everyone.
Yes, sir. And for our speakers, sir, almost 50 school students are there, sir, across
Okay.
Tamil Nadu, and a few from West Bengal, as well as from Abu Dhabi and Dubai also, sir. So I think the students are quite very dynamic. Even last time presentation also, they have been more proactive. So maybe after the session, even we can have interactions with any queries are there also, sir.
Okay. 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 Thank you, Google, for this opportunity. So some 2 3 days back, he called me and asked, "Why can't you give one talk about rockets and its components?" And I told, "Okay." I gave some official engagement and all. Then he told by evening also, "Okay." So like that, this today 6 p.m. as fixed. I'm as Google told, I have written almost 25 books in Tamil, 12 of them available in English. Totally 40 books plus is there now. Malayalam, Kannada also few books are there. So this topic, whatever I am going to tell, everything will be available in my book in the very detailed way. So now we will listen this component of rocket. Before going to that, we will understand some basic history behind this rocket and as well as some basic science. Okay. So what is the principle of rocket? Everybody studied third law of Newton, third law of motion. What is the third law says? For an equal, for every action, there is an equal and opposite reaction. If you take a balloon, you fill the air, then you after that you remove that mouth, so whenever the air comes out from the balloon, it will makes the reaction force that will moves the balloon upwards. That is the thing. It is not the upwards, the what direction you are keeping, it will give. Suppose if you tie the balloon in a rope between one point to other point, in that rope you are putting one straw and holding the balloon also in that rope means, then this balloon will move in the direction where the rope is tied. That is the concept. Similarly, if you burn a fuel and if you generate the exhaust gases, if exhaust gas is thrown via a small opening called nozzle, then it will create a force. That force will be create a thrust that will be useful to push the rocket. That is the concept. Okay. So there liquid engine, solid engine, there are so many things are there. This is the basic concept of rocket. This in this line only we are going to study. So once I told fuel, there are different type of fuel available. Say whatever we are seeing is from the crude oil, whatever we are extracting, all we call as a fuel. Before this rocket story, there is a small history behind this. In the 19th century only, we found the crude oil. So that middle of that 19th century only, we found how to extract different things from the crude oil. So those days before petrol and diesel engine were discovered, people were using this crude oil to get only kerosene, and kerosene lamps they were using. That is the main purpose of this crude oil. So later only they found that petrol engine in 1876 and 1890 diesel engine, they found that it is a great opportunity for the crude oil extraction and the distillation of this crude oil. Okay. So then petrol was called as a white gold and all. Then from the day onwards, the development towards the all the area, how to use this energy, both petrol and diesel, how to build a very stronger engines, that concept was started. So before here, we know that all are fuel, all are energy. Suppose you are taking a two idli in the morning, some fuel you are getting. If you are taking a one chocolate, so chocolate also you will get a one energy. So there are each fuel have a different energies. Example, if you take a butter or one dairy milk chocolate, if you eat 1 kilo of dairy milk chocolate, so you will get 22 megajoule. Suppose you are taking a 1 kg of banana, you will get only 4 to 5 megajoule of energy only. So rice also 5 megajoule. But the human body is required per day is 10 megajoule per day. If you tell in kilocalories, something like a 2500 kilocalories. So like that, each propellant, whatever we will use, each fuel what we'll use, that is called coal, coke, or our LPG will give some energy. When the rocket also uses this some energy, so this energy when converting into kinetic energy, we will not get all the energy. So when the exhaust, so when fuel, when you are firing, you will get the exhaust gases. This exhaust gas will be traveling through a okay, my mouse is visible. Yeah, traveling through the nozzle. When it travels, some of the energy will be absorbed by the heat losses of walls. Before that, there will be a combustion losses, that is poor mixing, incomplete burning, all will be there. Then later, some other point will be unavailable thermal energy to the exhaust gas. So full thermal energy will not get. Then residual kinetic energy only will pass through. So that effectively we will get only 40 to 50, 60 percentage only. So means if I have some particular energy in my propellant, when it comes out, I will get hardly half of the energy only. That only it means. But before that, what is fuel? What is propellant? That differentiation we should understand. To understand that, we will take an example of our aeroplane. So aeroplane, it travels in the air, but it travels in the air regime. Okay. So when if you go above the earth, if you go to 10 kilometer, 20 kilometer, something like that, till 30 kilometer altitude, 90 percentage of air is there. So if you go 70 percentage, 99.9 percentage of air will be below the 70 kilometer. If you cross 100 kilometer, it is called as a Kármán line, also known as space starts. Okay. So when you go out of air, means space, when you are going, there is no air there. So any fuel, if you want to burn, we need oxygen. So if rocket is goes out of air regime, then it is going to the space. To fire the fuel, whatever in the propeller, in the rocket fuel, we need a oxygen. So this fuel plus oxygen combination we are calling as a propellant. So rocket, what we call as a propellant, when car or bus or aeroplane, we will call as a fuel. That is the difference. So when a rocket goes, the rocket has to take this along with the fuel, it has to take oxidizer also. That is the message. So you come to the our old story. So immediately petrol engine, diesel engine came. That time only Wright brother also started thinking of how to use this petrol engine and try to fly. So that way only they designed the engine in 1903. Whatever that Wright brothers designed engine is a petrol engine basically. With the help of that engine only they were flying. Then later there is one more gentleman called Robert Goddard. So he was an American engineer. He also was trying to make a rocket with the use of gasoline. So he was used this gasoline in 1926. He made one rocket. So that was the first rocket. That the first rocket was so happened that it is a liquid engine. Then this liquid engine rocket was rose by almost 41 feet and went totally 184 feet in a 2.5 second. This is the first discovery of a flying rocket concept. Okay. Then Second World War started at 1939. That time Hitler thought we had to build a powerful rocket, so he made one V2 missile. So that missile was having a bigger capacity. It was traveling something like a 300 kilometer plus. It has 300 and almost 300 and no, no, 3,800 ton fuel as well as 4,900 oxygen. So like this story goes. During this period, before this Goddard is found this rocket and all, there is parallelly some more histories happening. One is one famous person called Hermann Oberth. He was the originally proposed when we want to fire a rocket, it has to go from Earth to some other planet. How where we have to fire? When we near to the Earth, we will be means rocket will be moving in the higher speed. When it will be away from the earth, it will be moving in a slower speed. Okay. So when slower speed, when you fire, we will not get the higher energy. When we will come to the near to the earth, apogee perigi irukkalingna, when we come to the near to the earth, if you give the add the additional velocity, so half mv squared, that we already square, so we will get extra energy. That this Oberth only found. But anyway, that was his PhD, but his PhD was not accepted those period. That is 1922 when he was telling this concept, people unable to imagine this concept. His students only later developed the powerful rocket like a Saturn rocket, which took man into the um, uh, moon and all. So one of his student is Von Braun. So Werner von Braun he was originally in the originally in the German team to develop this V2 missile. Later he moved to America for developing a rocket. Okay. So parallelly during this time, Silowski has found that rocket equation. So each stage, how much velocity addition to be required. Like that, parallelly, so many things happened. Sergei Korolev, he was took the charge of the Russian space mission. So parallelly, the rocket development and all going on. Okay, with this history, we will go to the rocket components. The first thing is now already I told we need a propellant. So when the fuel plus oxidizer is there, this combination called a propellant. So rocket has a propellant. So to burn the fuel, we need oxidizer. Rocket is carrying a both the thing. Up to that, you may be clear. So what the propellant is, there are two types of propellant we are using in a rocket. One is the liquid, other is the solid. Gaseous fuel and all will be high pressurized and low temperature, it will be converted into liquid. So we can tell only liquid and solid propellant. So typical liquid propellant and all, it can be earth storable. What is mean by earth storable mean? Say our petrol is there. Petrol we are filling in a normal two-wheeler tank or a car tank only. We are not keeping any specified temperature limit and all. It can be stored in the normal temperature, room temperature. These type of things all are called earth storable propellant. That hydrogen peroxide, nitric acid, nitrogen tetroxide, everything. So here both fuel and oxidizer both will be it will be stored here. The second is cryogenic propellant. So what is mean by cryogenic is when the fuel is stored the temperature between minus 150 degrees Celsius to minus 273 degrees Celsius, then we can call as a cryogenic propellant, like a liquid oxygen and liquid hydrogen, these things and all called. So methane also one type of propellant, but methane will be stored at minus 161. If any one is the semi-cryogenic condition, one is the normal room temperature condition, then we'll call as a semi-cryogenic thing. Otherwise, it will be called earth storable or cryogenic. This is the thing. So, for the normal thing, liquid engine, the liquid fuel will be stored in separate tank. Oxygen will be stored in separate tank. In the combustion chamber, both will be pumped together. In combustion chamber, both will meet. From there, it will ignite, and with the help of igniter, it will ignite. Some fuels are it is hypergolic, so when both is touching, immediately it will start fire. then it will be in the combustion chamber, it will fire and exhaust gas go. That is the concept how it goes. If you come to the solid propellant, unlike a liquid, so solid propellant, you have to prepare the fuel. See, first you have to take on fuel. After that, to burn this, you have to take oxidizer. So oxidizer, which is the element which is give oxygen during the firing. So when you mix these two, it has to be joined together. It has to bond. It has to bind. So for that, some binder will be there. Then how fast I have to fire? That also I have to be decided. For that, I will add some additives. So everything will be mixed together. This mix will be put in a oven for 60 degree, 70 degree, few hours, maybe few days also, up to 100. Then you will get a one paste. That is, once mixing, you have to cast it. After casting, you have to heat it in oven. Then you will get a casted mortar. So this will be solid. Sometimes hybrid also they were telling, means one fuel, say fuel may be in solid, so liquid oxidizer will be there. Oxidizer will be fired. It will go and touch on the liquid. It will fire. But the bigger motor and all hybrid is a difficulty due to the limitation. We never use either solid or liquid only. This is the concept. So what you are seeing is one picture. This was the original motor planned in Saturn rocket to take the human beings into the to the moon. So this has a 260-inch diameter solid motor. So means something like a 6 meter. You can think when this motor is fires, 1,800 ton of thrust will be generated for generated. So 1,800 ton. That is the power. That much powerful motor. Before going to how much, what are the components in rocket, we'll try to understand how many parts will be there in your day-to-day life products. Hope some of you noting down what I am telling with a paper and pen. So just to look in your pen, okay. How many parts are there in your pen? I typically taken my pen what I have used yesterday. So this pen will have this is a spring-loaded pen. There will be a spring will be there, top part will be there, the nib will be there, then the cap which I am using to put in my pocket, it is there. So like that I have a 6-7 product. If you go to the bill of material of a simple car, so car will have like this. So 5,000 to 20,000 parts you can see in a car. Okay. So what are the parts it will be put here? Parts and inner parts. Say suppose I have one screw, M8 one screw is there. The screw can be a 10 number or 20 number, 30 number, like that. So many parts will be there. In the same line, if you imagine rocket, so rocket will have so many parts, everything will be assembled together. Finally, it will connected by the wire harnessing, everything. Based on the rocket, up to 1 lakh parts will be there in the rocket. From the smaller rocket will be smaller. When you go higher and higher, it will be higher. Solid motor will be less and liquid will be higher. So then how will you design a rocket? Say I told that, see for a rocket, the propellant is main important. The propellant mean it consists of fuel and oxidizer. By simply firing this propellant, we will get a exhaust gas. This exhaust gas will be moved through a nozzle. Due to that, we will get as per the Newton law, we will get on reaction force. That force will push. So idea is as much as possible, I have to fill a fuel in my rocket or rocket stages. That is the idea. So assume that if you are going for a long trip, okay, somebody is sitting in Chennai going to Bombay or Delhi or Kashmir, something like that. So you are buying, one person is buying a bag, the bag weight is 10 kg. His luggage is, his dresses, whatever makeup item, whatever everything put together only 5 kg. One fellow bringing a 1 kg bag, other person is bringing a 10 kg bag. So both luggages are 5 kg, means their cloth. So the first person will be 10 kg bag plus 5 kg this luggage. So totally 15 kg he has to carry. The second person will bring only 1 kg bag, maybe a cloth bag. So 5 kg is cloths. So 5 plus 1, 6 kg only. They were taking the same luggage only. One fellow taking a 6 kg weight, other fellow taking 15 kg weight. So which is optimal? 15 kg is unnecessarily load. So for carrying that, you may not carry. You have to ask somebody help. You have to call labor to lift the item. Even aeroplane, they will charge you more. Everything will be there. So the same concept applicable to rocket also. When rocket designed, you have to make sure that the system which is holding the rocket stages, the inter stages should be as minimum possible low weight. The stages, that is the propellant tank, nozzle, actuator, whatever components which is support to store the propellant as well as divert the thrust and gimbal the thrust, everything should be as much as lower in weight. So such a way the design should be there. In typical, you can see here the Saturn rocket, the first stage weight is 2290 ton. In the 2290 ton, except propellant, all other things, whatever we tell these masses, stage masses, means the holding, everything put together only 130 ton. It is a less than 10 percentage. If you take the total this rocket, the total mass of the propellant will be more than 90 percentage. All other structures will be less than 10 percentage. The best design of rocket we will call only when this number is going high and high. In the world, the highest efficient rockets are having this mass ratio of something like a 93 to 94%. But same thing you take a car, okay. So car, if you are given one typical car here, so car will on this car weight is something like a 1058 kg. Here, five people can sit, some 400 kg you can assume, luggage of 200 kg you can put, to fill that 35 kg of fuel I can put. So payload to the total. So the total weight will be car weight plus all people 1693. So total weight what it is carries is 600. So the efficiency is 35%. In this order, if you compare rocket, it will be still lesser. What is the thing is, to understand this, what I am trying to explain now is payload versus total mass of a rocket. Okay. Hope I am audible. Things are going well. If any issues there, organizer or Google, somebody can call me. Okay.
Yes, sir. Very audible, sir. Very audible, and we could able to see all the presentations.
Okay, good. Okay, so now you just think of cycle. Hope everybody riding a cycle. Say, can you lift the cycle anytime? So this one typical cycle. Now different varieties of cycles are there. If it is the iron rod, if it is there, that cycle may weight around 20 kg. If it is the aluminum alloy wheels and aluminum alloy base, it will be still 14-15 kg. There are modern cycles, race cycles are there. It is made of the carbon. It may be 8 kg. So assume 20 kg cycle can lift two people. One person can ride, carrier if it is there, second person also can sit. So you and your friend is sitting in a cycle. So 20 kg cycle capable of taking to the 100 kg payload. So 5 times. The earlier my car story what I told, 1000 kg weight, it is taking only 300, means 30 percentage only. So here it is a 5 times, means 5 times mean it is a 500 times. 500 times becoming 35 percentage in car. If you go to aeroplane, it is 25. If you take a rocket, so this is a rocket. Last month you are seen it is took the Nizar satellite into the orbit. The total mass of this GSLV is 420 ton. Okay, the overall length is around 49 meter. This total rocket when it is lifting of 420 ton, but whatever the mass of Nisar satellite it took is only 2300 kg only, means it is almost 0.5 percentage. That is the ratio. So why this percentage is, so rocket is carrying the own oxygen along with it. That is the point number one. Second, it has to give a high kinetic energy to the satellite to be to be sent in particular orbit. That is the two things. Then it is traveling against the gravity, all those things and all coming. So if I put a new rule, today onwards, who are all listening from your hometown, you should not take the for your car or two-wheeler, you means your parents, they should not take any oxygen from the atmosphere. They have to fill the oxygen during the when filling their petrol. If such a rule is comes, for each 1 kg of propellant, you have to fill 14 kg of oxygen. Then only your car will travel. Say our earlier calculation, so 35 percentage of car, it will come down drastically. Since when I am filling a 10 kg of propellant, I have to fill 150 kg of oxygen. So that's why the rocket, it takes only the fuel, say solid motor case only 17 percentage of fuel. To burn the 70 percentage, I will take 70 or 69 percentage of oxidizer. That is the thing. So you can get that feel. This number I was telling typically on one orbit, but if you go higher and higher orbit, the percentage of load it is taking to the orbit will come down. Example, if you take a Saturn V rocket, this was the heaviest rocket ever made in history of humankind. 3000 ton is the lift off mass. It is capable of taking 140 ton to the low earth orbit, say 500 kilometer. So that like a 4%. If you same thing to the GTO orbit, it means 36,000 kilometer, it comes down to 0.9%. Assume that it is landing on a Mars, it can take only 0.005% of its own weight only. So, hope I am audible.
Yes, sir.
Okay. Okay. So now if you see that how the nozzle stages are planned. Suppose if you are going to the on mountain trip, okay, so you have to walk for one full day for that morning breakfast, noon breakfast, and evening snacks, everything you have to pack. So when you are packing on breakfast, everything you are separately packing. Then after packing, you are traveling to the mountain. When you are taking a food, after that empty paper or empty cover will be there. Na? Are we going to take that cover or we'll simply throw into the dustbin? We can carry, but when we carry, the unnecessary load will come. So last 10 year or 15 year, whatever chocolates or whatever snacks we are taken, if you store that cover in our house, it will be a huge load. Similarly, when rocket goes up and up, it will be designed in multi stages. Once the stage is over, carrying that stage will be unnecessary burden for the rocket. So that stage will be separated from the main thing. Okay, that is the thing. So that when you are separating, next stage will take care. But the ideally thing is, if my rocket is have a n number of stages, say 100 stage, after each stage I can remove one stage will be advantage. But there is a practical difficulty. Assemble is more number of stages. So that's why in general rockets will have a minimum 2 stages, maximum 5 stages. That is the optimal thing. Then how stage numbering will be given is, you can see the main booster will be there. I have put the same GSLV rocket. So to support this main booster, I will give a strap-ons. Okay. So the strap-ons will be there. The strap-on will give a force to the main booster. When it put like this, we'll call this a zeroth stage. Other one is called as a other one we will call as a main booster. Then this is strap-on. If suppose this booster is fired separately, then the main booster, then it is called first stage, second stage, like that. You can see some rocket, it will be there. Okay. So now rocket goes, my stage is burnt. So now whatever the stage I don't want. So now I want to remove the burnt stages. What I supposed to do is, so suppose you are splitting a two object. You are moving in a bus. Once bus is not stopped, before bus is stopping, you want to jump from the bus. What will happen? So you're just jumping, bus is going at 2-3 kilometer speed, but the momentum of you and the bus will be the same momentum. When you are jumping, you will be having a more energy than bus. Since your body mass is less, you will move ahead of the bus. Okay, that is called this momentum. We will tell mass into acceleration. We are telling one big ball is hitting on a small ball will move a higher thing. That is the thing. Similarly, when the moving rocket, if you remove the stage, this moved part will be travel in a faster speed than the main rocket. It will go and hit. So this you should avoid. You see here on S200 after separation, how you are doing that. For that, we will give a separation motor that we will call as a retro motor. We will call. Okay. So this retro motor will fire in opposite direction or sideway. It will remove the burnt stages which is not hitting on the main motor. Like the different motor you can see, retro 1, retro 2, separation, then like that you can see. Then the second, in a bottle, if suppose you have a water bottle, your full bottle is full, then your one chip of you are taking. So top 100 ml is empty. So that volume will cause ullage volume. When rocket is moves, so you will have this ullage volume in the liquid engine. So when the this particular stage is not firing, some other stage firing, the whatever the fuel or oxidizer is there, that will move on the upwards due to the rocket movement. So you will have an empty space on the bottom. But prior to firing this particular liquid stage, we have to bring this fuel to the bottom where the your engine outlet is connected. So for that you will fire some ullage motor also. That also one component. To simply explain how it is there, once again, there is a fuel, oxidizer, both will be pumped to the combustion chamber. So once combustion chamber it is there, it will fire and it will go out. So how much thrust it will get will be proportional to the mass, how much mass we are firing. and what is the velocity at which this exhaust gas goes. This only you will get. In some cases, there will be a pressure difference will be there, the exit to the atmospheric. So that also will give a small thrust. Then one question will come. So how this fuel are rated? So when you buy a car or a bike, we'll tell what is the mileage. Some car is giving a 10 kilometer, some car is giving a 20 kilometer mileage. So like that, the term we will define in a rocket fuel called specific impulse. What the specific impulse says is, if suppose I give a unit, 1 unit of fuel, means propellant you can call. Suppose I give a 1 kg of propellant to you, it has to produce 1 kg of thrust. How long this 1 kg of thrust it is producing, that is given by a specific impulse. Suppose I give a 1 kg of fuel, it is generate 1 kg of force for 200 seconds. Then my specific impulse is 200 seconds. That is the idea. So solid mode rocket will something like a 280 to 300 will be there. Hybrid rocket slightly better. Earth storable by propellant and all 300 to 330. Then cryogenic will be 450. Like that, different numbers are there. Anyway, solid, liquid, everything I told. Solid will be a simple in design, reliable, long storage, but it cannot be shut down once it is fired. Okay. But liquid is start and stop is possible, but higher ISP. If you want to fire the more second, then liquid only possible. That's why if you take a solid motor, the maximum action time of solid motor will be 2 minutes only, but liquid till 10 minutes, 11 minutes also possible. These all are the advantage. Okay. In solid motor, how you want to burn it? When the rocket it start from the earth, so it has to travel slowly in the atmospheric region. Means in the earth it will start from zero velocity. Anyway, the earth rotational velocity it will have. Earth rotational velocity something like 1,600 kilometer per hour. When it goes to the atmosphere, it will go to 5,000, 10,000 like that. When this going to the thick atmosphere, the friction force will be high, so it will go slowly. Once it is crossing the atmospheric region, it will travel in faster. So that's why you can see that different profile. So when it travels in atmospheric, I have to travel in slowly. When I am crossing the atmosphere, I can go faster. So what way I have to go, how much thrust I need, that will be decided by the burn rate of a solid propellant. In liquid engine, it is not required. They can simply pump the liquid and oxygen accordingly. That will be decided. One of the main part of this rocket is nozzle. So what nozzle does is, when you fire a propellant, you will get a exhaust gas. Instead of simply sending exhaust gas out like our balloon story, if you compress that the exhaust gas to the Mach number of 1, Mach number of 1 is what? Our speed of sound. Speed of sound we can take roughly 1200 kilometer per hour. Till that you compress it, then after that you have to expand. You are seeing here now, still you have to compress and you have to expand. Then the efficiency of this will be increased. Or by using this, we can increase 40 to 70% of thrust. To do this only the nozzles are put. So this nozzle will be a different types will be there. One may be the submerged nozzle, other will be the simple conical nozzle. You can tilt the nozzle sometimes. So many designs are there. Then where the brain of a rocket will be sitting. So rocket has to be control its own. It is a closed loop guidance. So when you give an input, what speed I will go, where I will go and all the data, there will be n number of sensor will be put on different parts of a rocket. At what speed it is moving, whether it is going in the right direction, whether I have to move gimbal the rocket, everything will be decided by the electronics sitting in the rocket. It will be put on the top of the rocket. It will called as a equipment bay. There it will be put all the control system. That only we are calling as a brain of a rocket. Sometimes in the individual stages also will give a smaller control system. So this only will control the full rocket. Then one more compound is heat shield. So if you see this is a Chandrayaan satellite, it was put in the LVM-3 rocket. The top of this rocket we are calling as a heat shield. Okay. So here only this satellite will be setting. It will be covered with a heat shield. So when it is going in the atmospheric regime, due to the frictional force, the satellite should not be disturbed. So to avoid that only we are putting. So heat shield will be there. But one more thing is here. When rocket goes, the exhaust gases comes, a lot of exhaust gas, tons and tons of exhaust gas coming out. It will generate the huge sound energy. So this sound energy will affect on our components, especially on satellite. To avoid this, inside this heat shield, what we will put is, we will put the sound absorbing material will be put, whatever white color we are seeing now. These are sound absorbing material. So these will absorb. So when you go to inside a theater, cinema theater, you will see very nice view of sounds, whatever that movie playing. Or if you go to the inside car, if you close all the windows of a car, it will be calm, will be there. Engine noise you will not hear, or outside road sound you will not see. These all are acoustic protection system only. Similar thing you can see. When the rocket goes, the rocket has to be moved to the direction where it has to move. Just think of a big ship, how the ship is moved. Ship will have a rudder. Okay, so propeller will be there. Propeller will be propelling continuously. Before that, on rudder will be there. This rudder, what it will do? This will give the direction where I should move a ship, opposite direction. So this concept is applicable in a rocket also, but in a different way. Assume that there is a pipe water is coming. You are just blowing a water. What will happen? This pipe water direction of flow will change. So this is called secondary thrust vector control. When the exhaust gases going in a nozzle, so you put a one high pressure stream of liquid. If you pump that on, the direction of flow can be changed. So that will change the rocket. This is the one type. Second type is combustion chamber. In the case of liquid engine, you can move the combustion chamber itself. That is called gimbal. So you move the combustion chamber, then that will move, then the direction of flow will change. Accordingly, rocket movement will be happen. Otherwise, in solid motor, we can move the nozzle itself. There we will put an actuator. So actuator will move, then the flow will be changed, then it will go like that. Then different pressure vessel will be there. How we are one of the fed pressure system is called pressure fed system. Say I have a fuel tank, I have an oxidizer tank. So I have to make sure that this whatever oxidizer and fuel is coming to the combustion chamber in the required flow rate. So next time when you go to the train and all, the new train LHP bogie they will call. You see that in a train, if you go to the wash basin or bathroom, water will be flowing. But the funny part is the water tank not unlike our house. Now house will have a in the rooftop or the highest point in your multi-story building, water tank will be there. But in the train, water tank in the bottom of the bogie where you are sleeping, in that underneath of that your sleeper coach, the water tanks are there. But how that water is coming from there to your wash basin? Wash basin lifted on outside. Similarly, car bottom only fuel tank is the top it is coming. For that we have one fuel pump. When running the fuel pump will come. Similar to that in this rocket what we will have is we will have a one pressurization unit. The high pressure fuel will be stored. So that fuel line will be given to the both fuel tank and oxidizer tank. It will maintain the always positive pressure that ensure flow is coming. So that's why you're seeing this whatever the gas bottles are there. Similarly, in solid motor, if you take solid motor will not have this combustion chamber concept. The motor itself will fire. When you are firing the motor, the inside this motor temperature will be increased. It will be something like a 40 bar to till 100 bar. So in this also one type of pressure vessel. So there this vessel has to be designed for 100 bar of pressure. Say the typical case HPS3 motor given here, it is designed for say 66 bar. This is for the shuttle motor. This is also something like that order. How this 66 bar? 66 means 66 times of our atmospheric pressure. If you take our pressure cooker, sometimes your house there may be a failure in a whistle, then your lid of the cooker may be lifted. So that lid, cooker inside is the pressure maintained is only 1.7 bar. Or if you take your cycle or a car, in the car the pressure is we will fill it 25 psi, that corresponds to only 2 bar pressure only. So only 2 bar only in our car, 4 to 5 bar in bus, but here it is something like a 60 bar. So that much pressure will come. So for that it is designed. As I told earlier, so pressure fed system I told there is we have a gas bottle, but if you have a bigger and bigger liquid engine, so that pressure fed will not work. Further, we should have a separate pump. That pump will call as a turbo pump. Same LVM3 rocket you take here, this middle stage called L110 stage. The L110, what it means is liquid 110 of 110 ton of propellant. That much propellant it is stored here. So roughly this stage will be operated 200 seconds. So in 200 seconds, I am consuming 110 ton of propellant. Means each second I am consuming 550 kg of propellant. So even our house tap we cannot consume. So we will have only a 1000 liter water tank that will consume for 2 days. If you take a car have a 30 liter, 40 liter. If I give a 550 liter of fuel to car, so car will run almost like a half of the year, 176 days it will run. So this much fuel I need every second. So means one L10 stage something equal to 10,000 cars. To that I need a powerful pump. That only we are calling as a turbo pump. Okay. So like that components also is there. When rocket is goes, we should know that where am I, where I am going. Say suppose rocket have a closed loop control. So it has to decide its own path. It has to tilt the nozzle and it has to control the some cases thrust control also is there. For that, it should know where I am, where it goes and all. For that, the two main things are there. One is gyroscope. So gyroscope will give an idea where it is in the three-dimensional space it is there, what rotation it is going, which direction it is going, what X, Y, Z, everything it will measure. Then it will give a feedback that will be used. Similarly, one more thing called accelerometer. So what speed it goes? Suppose I am going, suppose you are going in a cycle from your house to school. So your house to school is 5 kilometer. You are going now 10 kilometer speed, but you have to reach slightly faster. Then you should know that you are going in a 10 kilometer speed. I have to increase my speed to 15 kilometer per hour speed. Then only I will reach. Similarly, here also accelerometer will give where I am, where I reached in another 1 second, whether I am going in what speed, everything will be thing. Earlier, I told about heat shield. So heat shield is protecting the environment. There you can see the one thermal protection system, whatever this brown color you are seeing now. So when rocket goes, this on C60 rocket, I think you can see the image. Next time when you see the video, carefully you see, when it goes in atmosphere, it will be like this. When it goes to the thin atmosphere, the one coverage, whatever that heat, whatever it comes now, you can see that it is one fog is covered on the heat shield. So the components are designed for particular temperature. If you buy any item, say suppose your phone or a toy or whatever you say, there will be one rider will be there. Keep this in cold place. Keep it at 25 degree to 40 degree. Don't keep near to the stove like that. One rider will be there. Means the whatever the chips, metallic body, whatever you can call, it is designed to operate in a particular temperature. So heat shield is made up of say composite or metal. So that will be designed for operating in a particular temperature, say 60 degree, 70 degree. When temperature increases due to the air friction, then the ability of this material will come down. To avoid that, you have to give a one thermal protection system. This what it does is it will face the heat. It will make sure that the components are not affected by the heat. Like this, different parts of a component will have. Okay, we will come to the end of the presentation. Maybe one or two slide I will conclude. So parts of a rocket I'm going on explaining. There is one more thing you may be listening, missile. Okay, there are two missile concepts are there. One is the ballistic missile, other is crucial missile. Ballistic missile means you just use a rocket. You take it to the 10,000 kilometer altitude. From there you leave it free fall. It will come and fall. So that will concept of our whatever rocket I explained. Then second rockets what we are missile we call it, it will not go to the space. It will just travel only in the atmospheric region. It will have a powerful jet engine. Whatever the way it comes, it will travel and go. It will go a slower speed, but it will have a lot of maneuverability. So that is the difference. So ballistic missile, whatever the rocket components are told is applicable. Okay, with this just I will give main stages of two rockets and we will conclude. This is a GSLV. GSLV have three stages. The first stage is a GS1 we will call. This is S139 means solid motor 139 propellant is there. Fuel is HDBB based. Thrust whatever it will generate is 480 ton of thrust it will generate. Okay, it will operate for 100 seconds. The second stage, what we will see here, this stage is a liquid engine called Vikas engine. This is, we will call, okay, this strap-on also Vikas engine only. It is L40 we will call, 40 ton of propellant. Here also almost 40 ton you can say. This is the UH, this is the liquid, what is the given. This also will give a thrust of something like a 80 ton. It will operate for 150. The last stage and third stage is the cryogenic stage that is called C7.5. The 7.5 once again here means is 7.5 ton of propellant. It will generate 7 ton of thrust and burn time is 814. So how far you can see. Similarly, LVM3 which took the Chandrayaan mission to the moon. This also three stage. So first this strap-ons are solid motor. This is a 200 ton propellant. Main is L110 already I told. Then third stage is cryogenic, that is a 25 ton of propellant. You can see this further details and all in our ISRO website. So whatever I have told till now, you can find more interesting detail in some of my books. These books are available in English and Tamil. The one book called Rocket Science, it is available in Tamil as a Vinnurdi. The second book is called about how we are reaching moon, what are the R&Ds are happening in moon. That is that book is called The Second Trip to the Moon. You can find the details about all. Tamil it is called Nilavai Enum Kanavu. Regarding the what are the uses of this rocket and human space flight, astronauts, how astronauts are going, all those details are available in another book called Vinveli Manidhargal. This book available in English, Malayalam and Kannada also. You can find these books also. Then recently I have written one more book in Tamil about Sunitha Williams' trip. There also you find whatever this rocket story and all. Then I had one more opportunity to draft the biography of one NASA scientist called Kasturi Venkateswaran. He is the chief architect for this microbial experiment in JPL. Okay, he retired now. So you will find his interesting story of how these microbes are helping astronauts and day-to-day life. All those things he covered. This book in English available as a Deep Sea to Deep Space. Okay. Other than this, a number of books are there. You can find all my 40 books. I just given a list. All books detail you can find in this particular website. So you can go there. Whatever content also will be given in that book. So whatever you want to know, you can read. Okay, Google. With this, we will. I'm just coming to the last slide. If any question is there, we will go to the question answer session. Hope clear. All students noted down whatever I told. I just told very fast way. You can go there, read these books, so you will get a lot of idea what exactly I told.
Yes, sir. Yes, sir. Thank you so much, sir. So it was a wonderful session. You have done it for our the students of various schools from Tamil Nadu as well as from other states. So before we go to interaction session, maybe if Dr. Balamurugan is there, I think he can just give a small thought about this session also. Dr. Balamurugan? Okay. Okay, sir, he is not there. Maybe students can raise your hands for the question so that we can able to make you as a panelist and you can unmute your mic and you can ask more.
Good evening, sir. I am B. Chandra from class 9A, Velamma Vidyalaya, sir. Sir, I have a doubt on regarding hypersonic missiles, sir. Sir, in this hypersonic missile, we know that the missile is need to get control from the telemetry system, sir. But in hypersonic missile, the reaction between the hypersonic speed and the atmosphere should create a plasma around it, which should block most of the radio waves, sir. Then how are we getting the what is it? Controlling between the telemetry system and the missile, sir?
Okay, there is a two part. One is the controlling part. Second part, what you are asking, how this hypersonic is getting not conducted or not known by a radar. That is the thing you are asking. See, hypersonic, what I told, two missile. One missile is one concept is called ballistic missile. Ballistic missile is a rocket concept. So this goes something like a 10,000 kilometer speed. Then second one is the crucial missile. Crucial missile only having this one. There wherever the Mach number 1 means 1002 kilometer per hour speed is the 1 Mach. If hypersonic means it is supersonic, hypersonic. More than 3 times, more than 5 times. That only we are calling. So this control and all possible. Whatever way going and all it is possible. Rocket, satellite, everything possible. Only thing due to the high speed by radar contacting this thing and attacking or where it comes and all it have a limitation. That one they were telling it will be hide on the radar thing. Then second is the body will be designed such a way that the radar how it works, we will give a pulse, we will give some data, the data will go there and it will hit and come back. So by the way, we'll know that where the object is coming, what speed it is coming. So the missile body will be designed such a way that it is not known by the enemy country or whatever who is want to detect. That is one part. Second, radar we have some limitation. When ground you are sending something, it is traveling below 5-6 kilometer altitude, then also it cannot detect. So that way it is not detecting. Otherwise, controlling is not a problem. Then so most of the thing it will be go on a closed loop system. Okay, it will take care of where the target. Accordingly, it will take the path and move it, and it will go and hit.
Yes, sir. I understand, sir. Thank you, sir.
Sir, good evening, sir. I'm Sai Pranav from Puducherry, studying grade 7C in Pedisamana CBSE school, sir.
Yeah, please
So
go ahead.
my doubt is about hypersonic glider trajectory, sir. Sir, if hypersonic missiles are going at a low altitude, they may face a denser amount of air, no, sir. So it is better to have the long-guided ballistic missiles, which have a less fuel option, no. So then why do they choose hyper?
No, accuracy will not be there. Ballistic missile, like you are going to the 10th floor of your house or apartment, you are just dropping a ball. Okay. So it will go the way where you dropped, that way only it will go. But it is a crucial missile and all, na, it will give a trajectory. So if you one flying aeroplane is there, that aeroplane you want to chase, so you have to give a control according. When the aeroplane is moved, say suppose one army aeroplane moves with some speed of 3000 kilometer per hour speed, this also will move. It will move and it will go and hit. Okay. Okay.
Yes.
Today talk on launch vehicles, not on the missile. I just given a final slide to get a differentiate between launch vehicle and missile. I will appreciate if questions on specific to launch vehicle, it will be good. Audible? I am not listening anyone. Someone is talking.
Sir, I'm Kaushik from 11th standard. Sir, can you explain why does the cryogenic engines have more efficiency than other engines?
Molecular weight. When you do the propellant, now whatever this ISP is inversely proportional to the molecular weight. So whatever fuel we are using, na, hydrogen and all, it is a smaller molecular. Due to that only we are getting efficiency.
Thank you, sir.
Sir, good evening, sir. My name is Tushit. I am from Velama Multiplication Higher Secondary School, sir. So, when a rocket is using a propellant, the area occupied by the propellant will be used, no, sir. So, that area will become a vacuum. So, the propellant present inside the fuel tank will expand, sir.
No, fuel tank will not expand. There is a two
Not,
concept.
no, sir, not the
Are you
fuel
asking
tank, sir.
liquid engine or solid? Which one you are asking?
Liquid engine, sir.
Liquid engine tank will be separated. Both will be fired in the combustion chamber only. Combustion chamber, once firing is there, full combustion chamber under the pressure. Say 50 bar mean full combustion chamber from there to nozzle it will be 50 bar. Nozzle only it will expand. Their pressure will be come down.
Okay, sir.
Sir, good afternoon, sir. My name is Deepadhasan, studying in St. Anthony Medical Higher Secondary School, Brockton and Navy, sir. Sir, you can explain me the rocket equation, sir?
Yeah. You want to know the rocket equation or already I have explained na? Rocket
Sir,
equation
I want to know
nothing.
the letter.
Rocket equation nothing but earlier say one whatever suppose stage is there, one stage, initial stage and final stage. Suppose I have 100 kg of my stage weight, in that 80 kg is my propellant. So if 100 kg thing it is going to 80 kg, how much delta V will be added on each stage? If you want to launch one satellite to say 750 kilometer altitude, roughly I need a 26,000 kilometer per hour speed. So this how I can achieve. So I cannot achieve in the, I told na multi-stage. Each stage is give some delta. First stage may be 1.5 kilometer per second. Second stage may be 2 kilometer. Last stage 5 kilometer, like that. So that understanding came after this rocket equation formed only. You can find the more detail in that book.
Okay, sir. And how Mars is producing 270 tons of methane per day, sir?
There is a concept, say now when you go to the Mars, instead of coming back now, we cannot take the fuel. So if the fuel available in Mars, why can't we use the same fuel in the Mars and fill our rocket and come back? That is the idea. So for that only Elon Musk or other countries and all started making a methane engine. So methane, based on the study, whatever understood, there is a possibility of getting a methane in the Mars. So that's why the one study says this much methane is available in Mars. When we land, we can use this methane or get that methane by some extraction process. Then that can be used as a fuel for our rocket and come back. So that's why Mars landing rockets and all, they were planning use methane as a fuel.
Sir, good
Thank
evening,
you,
sir.
sir.
Yeah,
Sir, good
please.
evening, sir. I'm Harini from St. John's Metric Higher Secondary School, sir. Sir,
Go
am I
ahead.
audible, sir?
Yes, Janani, audible. Go ahead.
Sir, if a launch vehicle's upper stage carries extra fuel for a higher orbit, but the payload is unchanged, how does it affect efficiency and delta V for the first orbit, sir?
Oh, sorry. Pardon. Can you repeat your question? I am unable to hear you properly. Can you
Okay,
repeat
sir.
now?
Sir, okay, sir. Sir, if a launch vehicle's upper stage carries extra fuel for a higher orbit, but the payload is unchanged.
Google, can you hear her voice? I am unable to hear properly. Or you tell the question.
Yeah, no, her voice was breaking sir, for me also. Arini, I think some network issue. You can come
Janani,
near.
Janani, you put in chat. We will answer.
Affect efficiency.
Arini, your voice is breaking. Can you put it in the chat box so that we read and sir can give up the answer?
For the first orbit, sir.
Arini, can you hear from us? Okay. Maybe next question, I think she will join back. Some network issue.
Yeah, next.
So next question.
Sir, good evening, sir. My name is R. Sanjeev Kumar. I am from Velamal Vidyashram, sir. Sir, my doubt is that you said that rockets use gimbal thrust, which means that the whole combustion chamber is being tilted by some actuators, sir. So my question is that why we can't turn only the exhaust, no, sir. We can turn only the exhaust instead
Yeah.
of the complete combustion chamber.
That I told now. For a liquid engine, you have to tilt the whole combustion engine. Okay. For solid motor, there are two concepts. One, only you move the nozzle alone. That is called fluxing the nozzle. Second concept is just to move the exhaust alone. That is called secondary injection thrust star control. That whatever that boy photo I have put na. So, but that have some limitation. Only 2 degree only possible. For the gimbal and actuation, we can go up to 5 degree. So both mechanisms are there. That anyway, I put the fold. You can see that book. Full details will be given there. Based on
Okay,
the
sir.
right, stage, it will be decided.
Okay, sir. Thank you, sir.
Good evening, sir. My name is Prajwal Sanju from Grade 8B Wales Global School, Mogapet, Chennai, sir.
Yeah, go ahead.
Sir, I have a doubt, sir. You said that a thermal shield is covered around the rocket to protect it from the friction due to air in the atmosphere, sir. What material is used to cover it, sir?
Okay, it is not the full rocket. Only the region where the temperature is going beyond the capability of the material. Okay. So based on the rocket and based on the things, it will be different material. They will call as a cork sheet and all put cork phenolic sheet. Then some area PC10, there is one polymer system they were putting. So like that, different systems are there.
Okay,
You can
sir.
find
Thank you.
type in Google, you will find the details. Each rocket
Thank
have
you,
a
sir.
different TPS. You can put a thermal protection system.
Okay, sir. Thank you, sir.
Kalex Selvan. Or next question, I think Ilakia.
Yes, sir. Myself, Ilakya from Velamal main campus, sir. Good evening.
Yeah,
Am I
please go
audible?
ahead. Ilakya, audible, please go ahead.
Why do solid propellants usually use ammonium perchlorate as the oxidizer, sir?
Different oxidizer combination are there. Based on efficiency, they were using that one. So with 17% to 4 times only, with that 4 times you can get it. When you choose any material, oxidizer, there are different criteria are there. Criteria is how hazardous, how the cost, how we can processable that material, how to mix with the fuel, all will be considered. So in that ammonium perchlorate, one of the breadwinner for that solid motor.
Thank you, sir. Thank you so much, sir.
Good evening, sir. My name is R. Ananta Padmanabhan from Jawahar Higher Secondary School, CBSE, Neyveli. Sir, we know that the Tsiolkovsky rocket equation is fundamental, but in real rockets, we face drag, gravity losses, and engine inefficiencies. How do engineers practically adjust the triangle V calculations beyond the ideal equation, sir?
Oh, this is a engineering college question, na? So anywhere, whatever you are studying will be a preliminary study only. But when you go for the real rocket, where you are launching, what is the atmospheric, everything will be dictated. Okay. Even if you say that rocket during the rocket launch, how the airflow will be there, they will detailed study will be done. We will put the balloons up to some few kilometer, 5 kilometer, 10 kilometer, and all. If airflow is more than particular maybe kilometer per hour speed, then you cannot launch that particular day. They will tell our launch capability is this much only. So we cannot launch, it will not be there. So that study and all will be done. So that and all higher study you can see, but you can just search in Google, you will get the details. So these are only I told very basics, but individual design will call for all the things will be in picture.
Okay, sir. Thank you, sir.
Shape of the rocket also matters. Before designing any rocket, so whatever the shape is there, that will be put in the chamber, and they will apply the say now instead of rocket is moving, you keep the rocket body and move the air and test that how the aerodynamic coefficients and all accordingly they will design. All are there.
Okay, sir. Thank you, sir.
Good evening, sir. I am Nirmani P. from Srimati Sundaravali Memorial School, New Permuttur, sir. In the solid, I have doubts, sir. In the solid fuel boosters, you said aluminium and beryllium are used as fuels, but aluminium and beryllium are metals which have high melting points and boiling points, sir. How are they used as fuels, sir? They don't burn normally, right, sir?
Do you have any feeling? What is your feeling on exhaust gas temperature? You are seeing a rocket, rocket coming different colors.
Yes,
Can you
sir.
guess what is the temperature there?
3000 degrees Celsius,
3000,
probably.
yeah. You are sitting in your steel chair, not what temperature the steel will become a liquid?
1500.
Yes. So these all are much
Sir,
very
I
lower.
have another doubt. My doubt is that aluminum are generally not combustible, right, sir? How are they used as fuels?
This is not combustible. These all are put to increase the temperature. Okay.
Okay,
So
sir.
this is we are talking about coal, coke, petrol. These all are combustible product. So this metallic particle put in the whatever the solid motor is to increase the temperature. So that's why these all are put. Then second, density also matters. Okay, aluminum is a low dense material, 2.7.
Okay, sir. Thank you, sir.
Nirmania,
Google over.
I think Nirmania, one person has raised the answer. Nirmania, you want to ask anything? Okay, then. No,
Just a
I
minute.
think, okay, no questions from anyone. Okay, sir. I think it's all over. So thank you so much, sir. I think it was an interesting session. And students also have learned a lot of new things about today's sessions, especially on the components of rocket, because every component is very important, and that plays a very huge role for launching a rocket and putting the satellites into the orbit. So we appreciate our Sasikumar sir, who could able to spend this evening time with all of us, because even yesterday I think sir was quite busy because of the National Space Day, and last week also he was held up with a lot of traveling. So today he has agreed and he has given the wonderful sessions for all of you. So from our Agathiar and Ushago, we thank you so much, sir, for joining in the online and given a lot of insights about the rocket and its component. We are thanking from our bottom of our heart, and thank you, sir.
Okay, all students, say this is only a preliminary lecture only. Don't stop here. If you want to learn further on this all space trip and all, you get the proper book and read yourself. So some of my book also will help you. You just go to the site writersssc.com. Otherwise also some interesting thing will be there. You further study and you will get a lot of interesting things. Okay.
Yes, sir. Sure, sir. Maybe students would have noted down your website, sir. So maybe they will see and they will even like procure it. So maybe it's
Yeah, yeah.
instructions to students that, as sir said, whatever the presentations, whatever 1 hour, it's only like a kind of a drop of water. So you people have to go very deep and get a lot of insights from the people who have written books about this rocket science. And Sashi Kumar sir books and all, it's like very simple. You can easily understand. The Skyrider book is one very important. It talks about many things about the astronaut. So it will be very interesting. So you can see in his website and try to initiate his book, and you can read and you can even give a comment to sir also, so that anything you wanted to give a remarks, it always be taken to consider for next book. And we appreciate sir has gone almost for writing 40 books. So hope so we will be seeing his 50th book also in a very short period of time. So thank you, sir. Thank you so much, sir.
Okay, thank you. Thank you all.
Thank you, sir.